Hi everyone! In this video we will talk about special angles. First of all, these angles often occur in trigonometry and other branches of mathematics. And second, trigonometric function values for these angles form simpler ratios. And for all these reasons, we call these angles special. Here they are. These angles are 30, 45, and 60 degrees. In this video, we're going to find their trigonometric function values. And the story starts with an equilateral triangle. We know that the equilateral triangle is the one that has all sides congruent. That means that they're all equal. So I'm going to say that all sides of this triangle are equal x units. And I'd like to emphasize that all steps that we're going to see right now, they are applicable to an equilateral triangle of any size. What else do we know about equilateral triangles? Well, since all sides are the same, it means that all angles have to be the same, right? And if the sum of all angles in any triangle is 180 degrees, well, that means that each angle in equilateral triangle should be equal 60 degrees, right? 180 divided by 3 equals 60. Next, we're going to bisect one of the angles, and it's shown here. Since we're looking at the equilateral triangle, this angle bisector plays 3 roles. Well, being an angle bisector, it splits this angle in halves. That's 1. It's also a median, which means that it splits the opposite side into 2 congruent segments. That means that this is the midpoint of the base of the triangle. And third, the segment also the height of this triangle, which means that it's perpendicular to the base of the triangle. In other words, it forms 90-degree angles with the base. Keeping all that in mind, let's do the following. Let's split the original triangle literally in 2 triangles. And we already talked about how each angle here equals 30 degrees, right? Here the 90-degree angle is formed, and we have 2 segments that are half of x. But let's focus on just one of those halves. After all, they're exactly the same. So now we can say that is the right triangle with 2 acute angles that measure 30 degrees and 60 degrees. And what I'm going to do next, I will relabel the sides. Already I talked about how this segment here is x over 2, which means that its length is exactly half of the length of this side, right, which is x. And I can rephrase that and say that this side, which is by the way the hypotenuse, is twice longer than this leg. Would you agree with that? And that's how I'm going to label the triangle. So if this leg is n units, then the hypotenuse is twice longer, which is 2n. It's just easier to work with whole numbers rather than fractions. Okay, so here's the triangle again. Okay, remember that the topic of this video is special angles. And as you can see in this triangle, we have 2 of those special angles. We have 30-degree angle and we have 60-degree angle. So that's the triangle we're going to use to find 6 trigonometric function values for both angles. But before that, we need to find this missing side. How will we find it? Well, by using the Pythagorean theorem. Well, this unknown side I will label with a question mark. So by the Pythagorean theorem, we have to add squares of legs. One leg measures n units, and the other leg is, well, our question mark. That means that the unknown side squared plus n squared should be equal to the square of the hypotenuse, which is 2n squared. Now, when I square 2n, I need to square both 2 and n, so I'll get 4n squared on the right hand side. And now to find the unknown side, we first subtract n squared from each side. That gives us the unknown side squared equals 3n squared. And as we square root each side of this equation, we'll find that the unknown side equals n. That's me applying square root to n squared. And then 3 stays inside the radical, so n squared of 3. So now I can label it on a triangle, so n squared of 3. With that, we're ready to find trigonometric function values. Let's start with 30-degree angle. So sine of any angle is the ratio of the opposite side to hypotenuse. Okay, so for 30-degree angle, the opposite side is n, and hypotenuse in that triangle is 2n. So I got n over 2n, but I can simplify this fraction. I can divide out n, and I'll get 1/2. So sine of 30-degree angle is 1/2. And I'd like to point out here is that we're working with an arbitrary triangle, and that's why we label sides n and 2n and n squared of 3, which means that that triangle could be of any size. We could find a lot of similar triangles that will have 30, 60, 90-degree angles. And no matter how big or small that triangle is, if we try to find sine of 30-degree angle using that specific triangle, we will always end up with 1/2. So that is sine function value for 30-degree angle. Let's find cosine. Cosine is the adjacent side to hypotenuse. The adjacent side for 30-degree angle is n squared of 3. And the hypotenuse is 2n. And I'm going to divide out. And I'm going to conclude that cosine of 30-degree angle is square root of 3 over 2. Tangent is the ratio of the opposite side to the adjacent side. The opposite side is n. The adjacent side is n square root of 3. As before, I'm going to divide out n. And I'm getting fraction 1 over square root of 3. Since there's a square root in the denominator, I'll need to rationalize this fraction. I will multiply the denominator by square root of 3 and the numerator by square root of 3. So that means that in the numerator it's going to be square root of 3, and in the denominator it's going to be just 3. So tangent of 30-degree angle is square root of 3 over 3. And now let's do reciprocal functions. So first, let's cotangent. Cotangent is reciprocal of tangent. So what I can do, I can just get the result for tangent and obtain its reciprocal. Remember, we talked about how it's going to be easier and quicker if we use fraction that was not rationalized to obtain cotangent, and that is 1 over square root of 3. So I'm going to find reciprocal of that fraction. So reciprocal of 1 over square root of 3 is square root of 3 over 1, or just square root of 3. That's cotangent of 30-degree angle. Next, secant. Secant is the reciprocal of cosine. We know that cosine is square root of 3 over 2. Secant will be reciprocal of this fraction, which is 2 over square root of 3. And since we have radical in the denominator, let's rationalize it. Times square root of 3 on the bottom, times square root of 3 on the top. That is 2 square root of 3 over 3. That's secant. And finally, cosecant. Cosecant is the reciprocal of sine. Since sine is 1/2, the reciprocal of that is going to be 2 over 1, which is same as just 2. That is cosecant. Okay, so obtained all 6 function values for 30-degree angle, and you will be seeing these numbers a lot throughout the trigonometry course. Now, obtaining 6 trigonometric function values for 60-degree angle will be pretty much same process. So to save time, I'm just going to show you the result, and as you can see, numbers are very similar. So if you have time, you may want to pause this video and verify these numbers. Finally, let's obtain trigonometric function values for the last special angle, which is 45-degree angle. I already placed it in the right triangle, as you can see here. But to find function values of this angle, we need to know sides of this triangle. So let's start by determining the angle measure of that second acute angle. For that, I can just take 180 degrees, the total sum of all 3 angles, subtract 90-degree angle, and subtract 45-degree angle. And if I do that, I'll get 45 degrees. So this second acute angle is also 45 degrees, which makes this triangle an isosceles triangle. In this case, I can label sides of this triangle this way. If this side is n units, the other leg also has to be n units, right? So I just need to find the hypotenuse. And for that, we can use the Pythagorean theorem. We labeled each leg as n units, so that means that it's going to be n squared plus n squared equals, well, and then hypotenuse we don't know, so I'll put a question mark, squared. On the left-hand side, we can add like terms. We'll get 2n squared equals the unknown side squared. Then we'll square root each side. When we apply square root to n squared, we just get n. And then 2 stays inside the radical, so it's going to be n square root of 2. That's what that unknown side, which is hypotenuse, equals to. So I'm going to label the side accordingly. N square root of 2. And now we're ready to find all 6 trigonometric functions for a 45-degree angle. And it doesn't matter which one of those two 45-degree angles we're going to choose. We'll get same results for those 6 functions. Let's say I'll work with this angle here. We know that sine is the ratio of the opposite side to hypotenuse. The opposite side is n. The hypotenuse is n squared root of 2. Similar as before, we're going to divide out n. This will give us 1 over square root of 2. And of course, we'll need to rationalize the denominator, so times square root of 2 in the denominator, times square root of 2 in the numerator. So that will be square root of 2 over 2. That is sine for a 45-degree angle. Now cosine, it's adjacent side to the hypotenuse. Adjacent side is also n. Hypotenuse is n square root of 2. After we divide out n, we get 1 over square root of 2. That's the same result we got above, so I already know it's going to be square root of 2 over 2 once I rationalize. Tangent. It's opposite side to adjacent. The opposite side is n. The adjacent side is also n. As I divide out n's, I'll get 1 over 1 or just 1. Next is cotangent, which is reciprocal of tangent. Reciprocal of 1 is 1. That's quick. Secant. Secant is the reciprocal of cosine. Instead of using the final version of the cosine value, I'm going to use the one that was not rationalized. It's going to be easier to take its reciprocal. Reciprocal of 1 over square root of 2 is square root of 2 over 1, which is same as square root of 2. And then for cosecant, which is reciprocal of sine, we'll get same result. Right? Reciprocal of 1 over square root of 2 is square root of 2 over 1, or square root of 2. So that's how we obtain 6 trigonometric function values for the last special angle, which is 45-degree angle.